I share this one. The first most important thing about the radiation, that as we discussed heat transfer method from one place to another one. The first one, it was about conduction and then convection. So this is the third type by which you can perform the uh, transformation of energy from one place to another place. But this one is the different one in the radiation. In the radiation, there is no source of contact is required. Just like the conduction and convection, there are physical particles are required. So in the radiation, there is no physical part connection is required. This one is the important thing. And radiation itself is what? Radiation is the method in which we transfer the heat. But what is the difference thing there? We will continue. We will study in this topic. Right. First thing to start from here, radiation. Yes, Abdullah, please read this one.
Yes, sir. Radiation is a third way in which heat can travel, but whereas conduction and convection both need matter to be present, radiation can occur in a vacuum. Particles of matter are not involved. Radiation is the way heat reaches us from the sun.
Just like they give one of the very good example that radiation, whatever the radiation we are getting from the sun, this one is also the method from which we are getting the sunlight towards us. This is what? This is radiation, right? And the next one, next para from that one, radiation.
Yes, sir. Radiation has all the properties of electromagnetic waves, such as it travels at the speed of radio waves and gives interference effects. When it falls on an object, it is partly reflected, partly transmitted, partly absorbed. The part absorbed raises the temperature of the object.
So here, radiation is also one of the electromagnetic wave property. We will study in the upcoming chapter, chapter number 32. And the most important thing, what is the speed? The speed is equal to the speed of radio waves. And it will give the interference effect. We will also study this thing, what is interference effect over there. And then also, whenever the heat falls on any of the object, what will happen? Some part of it is reflected and some part will be transmitted and some part of it absorbed. So because of this absorption, you will find that the temperature of that object from which it is going to absorb will increase. Just like one of the example I can give you, if your car is standing outside under the sunlight, what will happen whenever the sunlight fall over it? So some part of the sunlight will reflect back and some part will absorb inside it. How you can find this? After some time, when you will touch the body of the car, you will find that it is hot. Why this body is hot? How this heat can come? Because of the absorption of this and under the process of radiation. Right? Now, note down this key definition of radiation there.
Yes, sir.
Okay, so what's the thing we get from here? The radiation is the flow of heat from one place to another place by mean of electromagnetic wave. It means radiation is traveling in form of electromagnetic wave. No physical particles are required, just like conduction or convection. And radiation is emitted by all the bodies. From all the bodies, radiation is coming out above absolute zero and constant mostly of infrared radiation. Because of this one, also we'll discuss this thing in chapter number 32, right? Many times you will find the question related with radiation. For the radiation, few of the terminologies are there, which are just like you can see in the beginning, good and bad absorbers, good and bad emitters, like this. So what are these? You can observe that some of the surfaces can absorb heat more. Which type of surface are there which absorb heat more? Yes, both of you.
Yes, sir.
Black surfaces, black
Good
surfaces.
observers.
Yes, black surfaces, you can see that they will absorb heat more. For example, if you will wear the black dresses and in the whenever you go outside during the sun time, so we feel that it is more hot. Comparative if we wear the white dresses or light colors, so they are not so much hot. Why this thing so? Why this thing going to be happen? Why black color absorb more heat and white color? Yes, and also in the black color. the dull black color, dull black surface will absorb more heat comparatively to the shiny surface, shiny black one, because some part of it, due to the shyness, due to the brightness, they will reflect back. But dull black will do what? They will catch or absorb more heat. And when we compare with the white surface, so with white shiny surface has a good reflector from which you will find more reflection. That's why less amount of heat will be absorbed with this. The next one, that what are the good and bad emitters? So from here, Alicia, can you read please? What's the what's the important point we get it, that what are the good emitters, what are the bad emitters? So some of the surfaces are there in which emissions are more than the others. Here they mention that whenever you have dull black surface, so this one is a better emitter of radiation than the shiny one. If you have the shiny surface, then shiny surface is not as much good emitter, right? And in the different places at the different purpose, we will use this type of good and bad type of emitters. Here he show this experiment, one of the experiment, what you read it. Here this one is. Here what the thing, you have a hot copper sheet. One side is polished and the other side is blackened. So whenever you will put the hand on the bed, both sides, so what you will observe, you will, what you said, that over there you will observe that which part, here you have painted black, they will give you more heat over there, right? The same technique we can use in vacuum flask as well. In vacuum flask, what's the thing is, okay, before discussion, read Abdullah, vacuum flask. In vacuum flask, what are these? The vacuum flask and thermos we use to hot object, hot liquids hot and the cold liquids cold. Also, some of the things you can see that boxes in which some shiny materials are present inside, in which you can keep your food hot or cold, sentence or maintain for the long time over there. So in this one, what's the difference is and how you can perform this thing? You can see this flask here. Can you see this here? So in this flask, first of all, we make the double layers. You can see there two layers are there with this blue lines. You can see with this double layers, what will happen? There is no physical contact at this place in between this. This one is a vacuum. There is a gap. That's why the heat cannot be transferred through the conduction, because in conduction, the material provide one particle to other to other, like this one. It will travel from one side to the other side. And here, because of there is no physical contact, that's why there will be no conduction there. Similarly, no convection here. So conduction and convection, almost you can say not no, but very less will be there, conduction and convection, because some part is still contact, in contact you can see here. Similarly, in the convection one, some of the particles will travel because of the gases. Try to vacuum out all the gases from these two places. Third one, the radiation. In the radiation, what we will do, we will make the inner surface, this surface. Can you see the hand of this one? This inner surface will become shiny. And because of this shiny surface, what will happen? The radiation will become minimized. So by taking these steps, we can do what? We can minimize the heat loss from this vacuum flask. So this one is basically what? This one is a good example in which you can show that how we can take care of conduction, convection and radiation there to maintain the temperature of hot or a cold liquid. Right? Any question related with this vacuum flask? Maybe they can ask about the vacuum flask and then the part of it. Yes, any question?
No, sir.
Sir,
Similarly,
I didn't understand
which
this
part?
vacuum thing,
They see in
the
this
gap
vacuum,
which you were telling.
because why we keep the gap? Because if it is in contact, if you keep the solid surface here, so what will happen? The heat can be transferred from this side to this side, inner to outer. Okay, so that's why they make the double layer inside of it. This blue color line shows what? There is a gap between these two surfaces, no physical contact there. And they try to take out the gases from there as well, that there will be no air in between these two layers. Can you see the hand cursor over there? Yes, Alicia?
Yes. Yes, sir.
Okay, because here I open in Foxit Phantom. Here I cannot use the pen as well. So you can see that these double layer are there. Two blue lines. Can you see this two blue lines? I make it
Yeah.
more. See these two blue lines there. So because of
Yeah.
these two blue lines in between, there is a vacuum. Vacuum means even there is no gas. They take out all the gas there. You can see here. He can mention this vacuum. So in this vacuum, why they keep this two layers separate and make them vacuum between? There is no physical contact between these two surfaces. Just a little bit there to maintain the box, but otherwise they have no contact. So because of no contact, what will happen? The heat will not go outside. The internal heat will not go outside from this layer to the other layer. If it is a solid one, what will happen? They catch the heat from the lower surface and then travel it towards the outside. So all the heat will be absorbed by that body. But here, there is no physical contact with it. So whenever you will cut down the flask or any of the old flask, you will break down and you will find that there is a vacuum side and there is two spaces like this by which you can maintain the temperature. Okay.
Okay.
If I'll find any of the animation, I'll share with you for this. The next important thing is about greenhouse effect. In the greenhouse, what we will do, we can absorb the heat from that one, or you can say we can capture the heat. What is going to be happen in this one? Okay, Abdullah, read this one. The greenhouse. Two types of phenomena. First thing, what he mentioned, that whenever the heat from the sun will come, it is not cut off by the sheet of glass because it can penetrate with the sheet of glass over there. Or whenever we have a fire heat, the fire heat can be blocked by the glass. What is the reason? Because the radiation from very hot bodies, just like sun, so they have very short wavelength, and this wavelength is infrared. This thing we will discuss. Infrared we will discuss in chapter number 32. So because of this short wavelength, they can penetrate from the glass and they can come inside the glass over there. And why we are using this? Because whenever we want to maintain the temperature of any site, for example, when we have the plant some places and we want to maintain the temperature, so there we will use the greenhouse effect. Because of this greenhouse, the sunlight will fall over there and the heat absorb inside it, and then whenever they will present inside of that one, you can maintain the temperature of inside it of that greenhouse, and then over there will be no issue to decrease the temperature, because when the temperature will drop down, the plants will die. So this one is also called what? This is also called heat trap, like this one, right? Because of this we can increase the temperature there. So this greenhouse effect is also very much important nowadays. And again, I will share with the video of that greenhouse effect, how it is practically work in one of the animation. Any question related with this general information about greenhouse, although they are not asking so much about the greenhouse
No,
effect,
sir.
but you must have the concept that why sunlight can penetrate and move inside the glass, and whenever the fire or some other types of heat cannot penetrate inside of it. Yeah. Any question?
No, sir.
Okay. So these are the few things which are related with these concept about the radiation. So here our topic, that transfer of heat, is finished there almost, but the topic heat is also finished, chapter heat. In this one, we discussed three important things from the yesterday's continuation: conduction, convection, and radiation. All these types of heat transfer from one place to another place. So any question related with these two as well, or comparison with all these three? Any question, then please ask, or we'll
No.
move on to the checklist. Okay, let's move on to the checklist then.